Saxon Advanced Math Lesson 68.c. This is applications of parabolas. I didn't put the parabolas. I slipped that in there in case you grab this lesson all by itself. You'll understand what we're talking about. I went ahead and put a regular parabola on here, and of course this is my focus. I'd have a directrix the same distance below. That's review from the last couple of sets with this lesson. But if I look at this, why parabolas are so important in actual life. Parabolas work on the angle of reflection, and that's the law of reflection. The law of reflection states the angle of incidence equals the angle of reflection. Now that's important because and if I want to think about it, if I were to have if this was a flat mirror and I had a source come down and hit right here, it's automatically going to come off here. Or if I threw a ball at the wall, right? If a ball came off and hit at this angle, I would automatically understand that that angle would be the same. And we do this without thinking about it. If we want to throw a ball at the wall and come back to us, we throw it at the wall at a straight line like this so that it comes right back. If I threw it at an angle like this, I would expect it to come off like that. That's the law of reflection. Now, where that comes in play with parabolas and why that's so important in everyday life, and parabolas are all around us when you start looking, is that parabolas allow us to redirect any incoming light or any incoming radio signal or any incoming whatever and redirect it to one focal point. Satellite dishes use this extensively in satellite dishes, headlights in your automobile, and let's talk about how that works, or a flashlight even, by changing that. So if I want all of the light to come out, so if this is my light source, and the light comes off here and hits, it's going to have this angle is going to be the same as this angle, and it's going to go off like that. Light that hits this way is going to go out like that. Even light that comes way out here off of this bulb is going to be reflected because those two angles are going to be the same. So in other words, I can take light, and if you've ever taken a part of flashlight and you open it up and you hold it up there, it's bright, but it's not like, hey, I'm going to light up the room or show it in one spot. But I put that parabolic mirror underneath it or put it through there and put the light bulb itself right at the focus, and I get a really straight light coming out. Now it's not perfect. There's still some spread of that light that you'll get to in a physics class someday, but the propagation of the light itself. But that light is going to go in almost a straight line, and it's because the angle of incidence equals the angle of reflection. Now let's talk about like a satellite dish. It goes exactly the opposite. That means that I can take the very broad satellite waves that are coming in, they're very, very weak, and I can take them and concentrate them all the way to, in a satellite dish, it's called an LNB. It's at that focal point, and it's facing, if you look at a satellite dish, if the dish is over here, it'll be facing the dish. It's not facing the satellite it's getting the information from. It's getting that information directly off of the dish itself, because it can take radio waves or light waves, it depends on what you're trying to accomplish here, and as it does so, it bends them, or reflects them, not bends them, sorry, reflects them back to the focal point no matter where they hit on that parabola. That's very important because that allows me to concentrate a very weak signal and put it into one concentrated point, and that one concentrated point allows me to focus them, and that's why it's called the focus. But this is very important with parabolas. You see them everywhere around you in life. You start paying attention to them. There are all sorts of reflectors out there that are using parabolic mathematics to get a more perfect signal or to focus light into a perfectly straight line. And just look around. You'll see the parabolas are used everywhere, and now you know the formula for finding it.